Hi, welcome to my video on solving polynomial inequalities. Polynomial inequalities is just polynomials that are written in general form or factored form, greater than or equal to 0 or less than or equal to 0. So we're going to solve this inequality. X minus 4 times x minus 1 times x plus 2 is greater than 0. Notice we have it's greater than 0. So if you have greater than 0, that means that you're talking about the positive values, and you're also greater than is not including. So it's not including the boundary. So let's look at what we call pretend this is equal to 0. So we look at the x-intercepts, or we look at the values of x that will make equal to 0. So if x minus 4, that means x could be a 4. 4 will give you a 0. If you look at x minus 1, then we're looking at a 1. And notice I can't put solid dot as a hollow dot because it's not equal to. So this is a 1, and x plus 2, so this is a minus 2. Notice I'm only putting in the values that would give me 0, as if it was a root or a 0 of a polynomial or an intercept. So we can't have negative 2, we can't have 1, we can't have 4, because it says greater than but not equal to. Now, as a result, what I do here is I pick a number on the right side, which is 5. I pick a number in the middle of 1 and 4, so let's call it 3. Pick a number between negative 2 and 1, so I'm going to pick a 0. And pick a number to the left of negative 2, so I'm going to make it negative 3. So I'm going to take each of these values and sub them in. So remember, greater than is going to be a positive. So if I put 5 into this bracket here, 5 minus 4 is 1, but I don't have to keep the value. I only got to keep the sign. Positive. Put a 5 here. 5 minus 1 is 3, so that's positive. And 5 plus 2 is 7, and that's positive. So you don't need the value of the number. So a positive times a positive times a positive will give me a positive for this expression. So when you put 5 in here, then the number will be greater than 0 because it's positive. Let's put 3 in. You put 3 in here, you get 3 minus 4 is negative 1. So we put a 3 in, we get a negative. You put 3 in here, and you'll get a positive. You put 3 in here, and you get 5, which is positive. So a negative times a positive is a negative value. So that means between 1 and 4, these values will be negative. And we put a 0 in. A 0 minus 4 is negative. 0 minus 1 is negative. And 0 plus 2 is positive. So that's negative times a positive is a positive. Now we're going to put a negative 3 in. So a negative and a negative is a negative. And negative 1 and negative 3 is negative when you add. Negative 3 plus 2 is negative 1, which is a negative. So that's negative times a negative times a negative is a negative. Notice that these are linears. So if you had y is greater than 0 or what, notice that this is a cubic. It would have been coming down here because it's positive, coming down through, going down, looping up, going through, coming up, looping down, going through. So it would have been like this. But we're only looking for the values of x that would be true here. So the values of x are going to be positive values, and we're not including these because it's greater than. We're not including, when I say boundary, but the points of x-intercepts are not included. So the result is positive. So positive is on this side, excuse me. So it's open at 4 going to infinity. And we're also positive here, so it's -2 open, and it's going to 1 open, and it's the union. So the values of x that will make this inequality true are the values between -2 and 1, but not including -2 and 1, and between 4, not between, greater than 4 to the right. And union means is including both of these. And pause the video if you wish and see if you can work these out. Don't forget. So again, we have an inequality. We have an x minus x plus 3. So that means x is going to be -3. And x is going to be -1. And x is going to be a 2. So those are the values of x that will make this equal to 0. And because it says equal to, that means the 3, negative, and the 1, that's negative, and the 2, that's positive. These values are included in this set. Whereas up here was greater than, not equal to, I put hollow dots on them, which means they're going to be not included. And to go further, we have less than, equal to, means that it's going to be, we're looking at the negative values, and we're looking at the points are included, and included will be a square bar. So here we go. Now let's look at plugging in. Let's look at greater than 2. Let's take a 3. In between -1 and 2, let's put a 0. Between -3 and -1, let's put a -2. And less than -3 would be a -4. Again, you can take a 4 or a 5 or a 6, or you can take 2.5, 2.1, but I take an integer. And between here, I can take 0, I can take a 1, or I can take any decimal number or fraction between these two. So I try to take integers as such. So let's take a 3 and plug it in here. And we plug a 3 in, we get +6, so it's a positive. Plug 3 in here, no matter what I sub in here, because I squared, it's going to be positive. So I don't even have to work it out. And plug 3 in here, I get a 1, so that's positive. So 3 positives multiplied is a positive. And put a 0 in. 0 in here gives me a 3, which is positive. Put a 0 in here, don't make any difference, I'm squaring, it's going to be positive. Put a 0 in here and I get a -2, so that's negative. So positive times a positive times a negative is a negative. Put a -2 in, I get a 1, which is positive. And no matter what I put in here, squaring it is going to be a positive. And put a -2 in here, I get a -4, which is negative. And multiply, I'll get a negative. Positive times a positive times a negative is a negative. And plug in a -4. Put a -4 in here and I get a -1, so it's going to be negative. And I'm squaring this one, so that's going to be a positive. And put a -4 in here, I get a -6, it's negative. So a negative times a positive times a negative is a positive. So we're looking for the negatives. So the negatives are right here. So notice, you say, well, how come? Notice here, because it's linear, on this side is plus, because it went through is a minus, because it went through then it's a plus, because it went through it's a minus, so they keep changing. But notice at x plus 1 squared, at a -1, it's bouncing off. So if you happen to draw down through 1 is linear, so it's going to go on through, it will come down through like this, and it will come up here, and it would bounce off like tangent, a double root, square. So that means if you're coming down from here and going through like this, notice on this side is negative, and on this side is negative. And so when we go through, because that's negative, we're going through, then this side would be positive. So anyway, the answer to this is because it's negative and a negative, so it's because it's equal to solid, it's a negative 3, and we're going on through, it's 0 is negative 1, so we're going up to 2, and 2 is solid, so square bar. So all the numbers, including negative 3 and 2, and all the numbers between negative 3 and 2, make this inequality true. Because again, less than is negative, and the negatives are right here into this interval. We can't go out here, that's positive, we can't go out here. So all the numbers on this side make this expression positive, and the positive number is not less than 0. And all the numbers less than negative 3 makes it positive, and we can't use them. Okay, let's continue. Solve for x again. And we have less than. Less than is a negative. And there's no equal sign, so the intercepts or the values of x are not included. They're not included. So what values? X is 0. So 0 is, let's put 0 for x right here, but 0 is not included. 2, let's put 2 right here, and 2 again is not included. And we have 4, let's put a 4 here, but a 4 is not included. And we have, let's go over further, and we have a 6, which is not included. So we got a 0, 2, 4, 6. So I'll have to take a 7, which is greater than 6. In between is a 5. In between 2 and 4 is a 3. In between 0 and 1 is 0 and 2, is 1. And to the left is negative 1. So let's plug these values into this expression. We put 7 in here is positive. 7 here is positive 5. 7 here is positive. 7 here is positive. So we get a positive, positive, positive. So multiply is positive. Put a 5 in. Put a 5 here is positive. Put a 5 here is positive. Put a 5 here, you get a positive. Put a 5 here, you get a negative. So you have a positive, 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 negative, multiply, and you get a negative. Put a 3 in. A 3 will give you a positive. A 3 will give you a positive. 3 is a negative, and a 3 is a negative. So we got a positive, positive, negative, negative. So when you multiply, you get a, let's put those up there. Keep it in line, and make that a positive. I want to keep them all in the same line. And we put a 1 in. A 1 is positive, negative, 1 is negative, and a 1 is negative. So a 1 is positive, negative, 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 multiple, negative, you gotta be careful. So it's positive, negative, negative, negative. So 3 negatives makes a negative. And we put a negative 1 in. Negative 1 here is negative. Negative 1 is negative. Negative 1 here is negative. Negative 1 here is negative. So that's a negative, 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 negative. 4 negatives multiplied is a positive. And we have to pick the negatives. So the negative, that's a positive there. Sorry about that. So we have to pick the negative answers. So the negative answers, negatives are intervals. So notice 4 is not included because there's no equal sign. So it's open at 4, comma, 6, open. And negative is here, 0 to a 2, and it's open bar because the 0 and the 2 are not included in union with. So all the values of x, that's between 4 and 6, and between 0 and 2, not including 4 or 6, not including 0 and 2. So it's a union. These are the values of x in this notation. Number 4, again, if you wish to pause the video, and we have greater than equal to, so greater than, we're looking for the positives, positive, greater than 0 is positive, and it's included. So the values or the intercepts or the zeros, whatever you want to call it, are included. So we're going to pick x is -1, which let's say it's right here, and we're going to pick x is 2. So let's pick here. So these are the two values that make this a 0. So equal to means it's included. So that means, notice up here is not equal to, so the bars are open because the endpoints are not included. Because this is an equal to, this endpoint has a solid or square bar, and it's equal to 2, so it's solid. So we're going to put in, let's see, we're going to put in greater than 2 would be a 3. Between -1 and 2 is a 0. And to the left is -2. So here we go. Let's put a 3 in. 3 plus 1 is 4 is positive. And 3 minus 2 is 1. 1 cubed is positive. So positive times a positive is a positive. Put a 0 in. A 0, it gives you 1, which is positive. And a 0 gives you -2 cubed is -8, which is negative. So positive times a negative is a negative. And put a -2 in. -2 plus 1 is -1, so that's negative. And a -2 is -4 cubed is negative. Negative times a negative is a positive. So notice this is cubic, and a cubic graph would have been coming down from here, like making a sideways S, coming down through, like coming down like that, and going over, and coming down, keep on down to come up through the y-axis at 0 would have been here. So it would come up through and go on through like that. That would be the shape of the graph. Sideways S, down, and then go up through like that. And because that's linear, at -1 it would go on through. So because they're not bouncing off, then you got a positive, negative, positive. Makes sense. So we need the positive answers. So the positive answers are, it's 2, so it's square bar, 2 is included, to infinity. And in union with, and we're picking up the positive here, so -1 is included, and we're going to negative infinity. So there's the answers. So all the values are to the right of 2 and including 2, and to the left of -1 and including -1. Okay, hopefully you're seeing the pattern that we're doing here. Remember, notation was done on the inequalities on the linears lines in the earlier units, so you should check that unit to also help you out. Again, we have a greater than, and a greater than is a positive, and there's no equal to, so it's not included. So that means x squared, we're looking at a 0, which is not included. We're looking at -3, which is not included. We're looking at a 2, which is not included. So these values that make this equal to 0, these values are not included. So the 2, -3, and 0 are not included. And so we look at numbers to the right, which is a 3, in between is a 1, in between pick a -1, and to the left is -4. So let's take each of these values and sub into this expression. So when you put a 3 in here and square it, it's positive. 3 here, +6, positive. 3 here is +1, so it's positive. So it's a positive, positive, positive. When you multiply, you'll get a positive. When you put a 1 in, 1 squared is positive. Put a 1 in, 4 is positive. Put a 1 in is -1, negative. So you get a positive, positive, negative. Multiply, you have a negative. When you put -1 in, -1 squared is positive. +2, positive, and -3. So it's a positive, positive, negative. Positive, positive, negative. Multiply, and you get a negative. Put a -4 in. -4 squared is positive. Put a -4 in, and here is negative. Put a -4 here is -6, which is negative. So you multiply, you get a positive. So we're looking for the positive answers, and the positive answers are here and here. here. They're not in between. Again, notice at 0. At 0 is a square, so it's bouncing off. So if you looked at the graph, if you had y equals, or y greater than or equal to, then it would come down through the 2, because it's linear, 1. And it would come down, it would bounce off at 0 and come, so it would be like that, and go up through. So the y values would be positive on this side and positive. So it's positive, not including. So it's, the answer is open at 2, going to infinity. Open, in union with, and we're looking for a positive way over here. So it's open at -3, going to negative infinity. Again, we're looking for greater than 0 is positive, but notice there's no square bars because the zeros or the x-intercepts or the roots of is equal to 0. So y values of x will make this expression 0. There's the 3 of them there. And number 6, notice we have a negative here, and we have no brackets, so we have to write this in factored form. But the first thing I'm going to do is multiply by -1. Negative times a negative is x cubed. Negative times a positive is negative. -1 times 4 is positive. When you multiply by a negative, the inequality becomes less than equal to. And -1 times 0 is 0. So I will remove the negative in the front by multiplying by -1. And when you multiply by -1 or divide by -1, whatever we want to do, then the greater than becomes less than. So as a result, we have to write this in factored form. So we check if you want. We got a positive, negative, imaginaries, and total. So there's x cubed, so we know there's 3 roots. And we know that there's one change here and one change. So there's 2 positives or 0 positives. Now we put a negative x in here and cube it, we get a negative. We put a negative x here and square it, we get a negative. Because a negative x being squared is x squared. -3 times x squared is negative. And we get the positive 4. So there's only one change here. So there's only one negative. So if there's only one negative, so you got 2 positives, 1 negative, you got no imaginaries. You got no positive, but you still have 1 negative. So that means you can have 2 imaginaries. But if these were imaginary roots, we wouldn't be able to find them. So this is not in play. So we have 2 positives and 1 negative because we can't graph imaginary roots on the number line, because this is the real number line, so it can't have imaginary. So these 2 imaginary roots won't be true because I wouldn't be able to graph them. And here we go. So I'm going to try the factors of 4. So the possible, this is a 1, so the possible factors are plus minus the factors of 4. 1, 2, and 4. Remember, it's the factors of p divided by the factors of q. But p is 4, q is 1. Because q is 1, then I just only got to look at the factors of 4. And there's one positive for sure, so I'm going to looking at notice the coefficients add up to -3 plus 5 is, so 1 is not a root, so I'm going to try -1. I know there's 1 negative, and so it's easier to probably find the negative. So let's look at 1, -3. Notice that x is missing, so it's a 0 and a 4. X cubed, -3x squared, plus 4. So the 0x, the linear term is missing, so put a 0 in. Draw a line, bring down your 1. -1 times 1 is -1. -4 when I add. Multiply. -1 times -4 is 4. Add 4. Multiply. -4. Remainder is 0. That means that x plus 1 is a factor. Okay, so now we have x squared minus 4x plus 4 equals 0. So that means we have x and x. Factors of 4 to give me a 4 are 2 and 2. The product is positive 4, the sum is negative, so that has to be negative 2, negative 2. So this is x minus 2 is equal to 0. X minus 2 is equal to 0. X is 2, x is 2. So notice we have, but this is x minus 2 squared. So the inequality could be written down as, this is a minus 1, so this is an x plus 1. This is x minus 2 squared is, and that's less than or equal to 0. So if you look at it, draw a number line like this, and we have negative 1, which is right here. We have a 2, which is right here, and this is less than equal to, so that's included. Less than is dealing with less than equal to means that it's going to be a negative, and it's included. So the endpoints are included because they're solid, because it's equal to. So let's put a 3. In between is a 0, and over here is negative 2. And we put a 3 in. 3 is positive. When you square it, it's positive, so that's a positive and a positive. Gives me a positive when you multiply. Put a 0 in, we get a positive, and this is a positive. Okay, so that's a positive and a positive, still positive. Put a negative 2 in. Negative 2 here gives me a negative, and this is going to be a positive anyway, so that's a negative and a positive, so it's a negative when we multiply. And we're looking for the negative numbers and their included. Again, notice that this is a square here. So if you come down, because it's come down from here, as a square, it bounces off. So it comes down, bounces off, goes up, and because it's a linear, it goes on through like that. So on this side is positive, because it bounces off, it's tangent, this is positive, and it's negative over here. So we want the negative, so the answer is negative 1 is included, going to negative infinity, open, in union with. Now notice we got equal to 0, so we can't have this side, we can't have this side, but we can't have the 2, so it's in union with the 2. So the 2 is a point, is an integer. So 2, if you put 2 into this expression here, it will make it equal to 0. So here, a negative 1 will make it equal to 0, and all values to the left of negative 1 will also make it true. So if you take any one of these values that fits in here, it'll make, sub it in here at the beginning, it'll make this positive, greater than 0. And if you plug in negative 1 here, you will make it equal to 0. If you plug in a 2 into this expression and make it equal to 0. So hopefully you understand the writing it up in the x-intercept form, in the factored form, writing it in the factored form and graphing them as included or not included at the endpoints and doing the intervals is the way that I do it. And notice I didn't plug in, really sub in to get the value. I just got the pluses and the minuses and then multiplied. And that's the quicker way to do it. And if you like my video, click on the like button, subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on the YouTube channel, Math Fully Explained. Hope you enjoyed my video and learned all about polynomial inequalities. Bye-bye.